Connolly. I started making videos for my own students, and this one's for them because it's a 5th grade video. We're going to be reviewing / introducing how to multiply a mixed number by a mixed number. So for today for math time, it's mixed number times mixed number. Okay? So if you have any other questions or topics you want me to cover, connollymathathome@gmail.com. So let's get started. Whenever we're thinking about working with fractions, less than a whole, greater than a whole, anytime, I always want us to remember what we know about whole numbers because that's going to help us with mixed numbers, fractions, all that stuff. So I want to go over a strategy that you know, and again, this is not the only strategy that we can use to solve these types of problems. I just want to guide you in one direction during this video, and then you can start exploring other ways on your own. So let's think about if we were multiplying 23 times 41. Okay, thinking about whole numbers first so that you can remember. One strategy that we had was using the area model to break both numbers apart. And we broke both numbers apart by place value. So let's give this a story problem context, okay? We walk into a gymnasium and the gymnasium is 41 yards by 23 yards, okay? So we're thinking about 41 yards going this way, 23 yards going this way. So what you might think about is splitting up the 41 into, by place value, 40 and 1. That's not the only way, but I'm just showing you one way. And then you might think about splitting up the 23 into 20 and 3. Okay, I know this is super review, but just in case, super review I said, I understand that we've done this a million times, but it's important that you remember this so we can apply it to the mixed numbers, okay? So we might think about this rectangle here being 40 yards by 20 yards, okay? 40 by 20, and we know that that would be 800 yards, okay? So 40 by 20. We know that opposite sides are equal in a rectangle, and so this piece here equals 20, and we would multiply it by the 1 yard here. So 20 times 1. Let me show you what I'm talking about. This side is 20, so this side is 20. Okay, and then we would end up with 20 yards here. 20 times 1. Okay, then we know that 40 opposite sides are equal in a rectangle, so we know that if this is 40, then down here is also 40. So we know that down here would be represented by 40 times 3, which is 120. And we know that if this side here is 3, then the length of this side is 3. And we know that if this side here is 1, the length of this side is 1. So down here would be 1 times 3. So we found the area of 4 different rectangles inside the entire gym floor. And in order to find the area of the entire thing, we have to add our subproducts together. Okay, if you're at home, give me a thumbs up if you agree, you remember what we're talking about. So we would add up 800 plus 120 plus 20 plus 3, and we would get our final answer of 943 yards squared. We're talking about 2 dimensions, length times width, so that's where we would get squared in my story problem context. Okay, so that was a very quick review of something that we've reviewed a million times this year. And now we're going to talk about how we can use that information to help us multiply a mixed number by a mixed number. Okay, so as always, there's some stuff that's we have in common between working with whole numbers and working with fractions. Okay, so let's say you are at a store and the dimensions of the store, this would be a really small store. Let's not be at a store. Let's be, I don't know, let's call it meters. Okay, so there's a little office that's 2.5 meters long and it is 1 1/4 meters wide. So you can barely fit your desk in there, but we're just gonna go with it. Okay, so let's draw this rectangle here. and find the area. All right? In the last example with whole numbers, we split up the whole numbers by place value. We did by tens and we did by ones. In this situation, we can split 2.5 up a different way. And I like to work with whole numbers. How about you? Okay, so I'm going to split 2.5 up by whole number. I'm going to keep the whole number here. And then by fraction. So this little piece over here is going to represent half of the meter. Okay? I gotta leave room for me to multiply inside, so I'm gonna make that a little bit bigger. All right, then I'm gonna do the same thing. Just like we did with whole numbers, I'm gonna think about 1 1/4 as 1 1/4. And I'm gonna split these up this way. Well, you wanna know what? It should kind of be similar to what's going on. This 1/4 piece should be a little bit smaller. Okay, so we have 2.5 represented on this dimension, 1 1/4 represented on this dimension. Okay, so what are we going to do? We're going to do the same things we did with whole numbers, okay? So in this piece here, this rectangle, we have a width of 2 and a length of 1. So in here, we multiply 2 times 1, which is, you got it, 2. Okay? Over here, we know that this piece is equivalent to this piece. So we know that we're multiplying 1 times 1/2. One group of 1/2, which you know equals 1/2. If you have one group of 1/2, it's 1/2. All right? So how are we feeling so far? Just checking in. I'm sure you can predict what's going to happen down here. So we know that the width here is 2. Opposite sides in a rectangle are equal. So we multiply 2 times 1/4. And you know 2 groups of 1/4. We can use repeated addition. 2 groups of 1/4 is the same as 1/4 plus 1/4, which is 2/4. All right? I hope you're still with me. Let's continue. Then we have 1/4. This piece here is equal to 1/4. So this one is the same exact length. And you know what we would multiply down here. Okay? You're used to this from whole numbers. So we know this is going to be 1/4 times 1/2. And something you also already know is that we can do numerator times numerator, which is 1. And we can do denominator times denominator, which is 8. Okay, so 1/4 of 1/2 is 1/8. So, just like whole numbers, we need to add all of our subproducts together. So, I see that we have 2 plus 1/2, 2 plus 1/2 plus 2/4. And then I'm going to have to erase this because I'm running out of space. So then I'm going to add this last one here, plus 1/8. Okay? So this is where, this is a problem that brings a lot of our math together, I would say. So what we want to think about is we have to add these 4 subproducts together. So what we have to think about when we're adding fractions is, do we have a common denominator? Or we want to think about, are there ways to combine fractions to make this easier for ourselves? Okay, so when I look here, I have 1/2, 2/4, and 1/8. They all have different denominators, okay? So you have a couple options here. You could make equivalent fractions so that you're working with the same size pieces. That's something that you could do, okay? So if I wanted to, I could make all of these 8s. So I could say 2 plus 4/8, because 1/2 is equivalent to 4/8. I could change this to 8s as well, make an equivalent fraction. So 4 times 2 is 8, so this is equivalent to 4/8. and then we have 1/8 here. And I think that you might be noticing something with me, that we have 1/2 plus 1/2 here. Okay, so 4/8 plus 4/8 is a whole. So this is the same as 2 plus 1 whole plus 1/8. And then we have 3 1/8 meters squared, because we were talking about the area of my mini office. Okay, so that's one way you could combine these. So all that you're doing is you're relying on what you know about adding fraction. Something that some of you all might have recognized as I was starting to talk about this is that these two were equivalent to 1/2. So we didn't have to do all that work with eighths. You might have seen that this is the same as 1/2 plus 1/2, because 2/4 is the same as 1/2. So you might have seen this from that step up there. Okay, so let's talk about what just happened. We relied on what we knew about whole numbers. We used the area model, but we broke up the dimensions by whole number and then by fraction. We found the 4 subproducts and then we added them, keeping in mind that when we add fractions, we need a common denominator. Okay, so we're going to do at least one more. Okay, so let's think about, we're going to think about 3 1/3 groups of 4 and 1/2. Okay, so what we're going to do is we're going to, the same exact thing as last time. You should be predicting with me what's going to happen here. So we are going to think about putting 1 factor as each dimension, okay? And then we'll solve for the 4 subproducts and then we'll add them together. So I'm going to be thinking about 3 1/3 on this as my width here. And then I'm going to be thinking about 4 1/2 as my length. Okay, so see what I did. I took 3 1/3, and instead of breaking up by tens and ones like we did with 2-digit numbers, I'm going to break it up by whole number and then fraction. I did the same thing here. Whole number, then fraction. Okay, then you carry out your multiplication as you always would. So 4 times 3 is 12. And I know if you're in my class, you're pretty familiar with what we would be multiplying in each of these rectangles because we practice the area model so much, okay? But just remember, opposite sides are equal if you're not sure exactly what you're supposed to be multiplying. So 4 times 1/3, so 4 groups of 1/3, we know would be 4 thirds. 1/3 plus 1/3 plus 1/3 plus 1/3, 4 thirds, okay? Then we come down here and we know opposite sides are equal, so it's 3 times 1/2, that would be the area, length times width. So 3 times 1/2 would be 3 groups of 1/2, which is 3 halves. Okay, then we get to our final rectangle, and we know that this piece is 1/3. This side is 1/3, this side is 1/2. So we do 1/3 times 1/2. I'm going to write it down here because I don't have enough space. When you're multiplying fractions, you know it's numerator times numerator and denominator times denominator. So we end up with 1/6 there. Okay? Then, just like whole numbers, we're going to add our subproducts together. So we have this to tackle. 12 plus 4 thirds plus 3 halves plus 1/6. All right, so there's a lot of things going on with here. I see fractions greater than a whole. I have this whole number here. I have a bunch of different denominators. So it's up to you how you want to tackle this situation. There's many ways to solve. Okay, so you heard it here first. There's many ways to solve. I think that I'm going to just make equivalent fractions so that all of my fractions have the same size pieces, and by that I mean the same denominator. But again, several ways to add this. All right, so I see 4/3, 3/2, and 1/6. I know that 3, when I count by 3s, I will say 6. So I know that 6 is a multiple of 3. I know that 6 is also a multiple of 2. So I know that I can make equivalent fractions and make all of these have 6ths as a denominator. So I'm going to think about 4/3. 3 times 2 is 6. So if I multiply my denominator times 2, I multiply my numerator times 2. So 4 times 2 is 8. And again, I have a fraction greater than a whole, but that makes sense because it's equivalent to this fraction, which is also greater than 1 whole. Okay? Then I'm going to think about 3/2. And if I multiply 2 times 3, I'll make 6. So I need to multiply my numerator times 3, which would get me 9. Again, fraction greater than a whole, fraction greater than a whole. It makes sense. And then that one is already 6ths. So I'm good to go there. So what I'm going to do is I'm going to add up fractions like we know how. And I see 8/6 plus 9/6 is 17/6 plus 1/6 is 18/6. I'm adding plus 12. And when we see a fraction that's greater than a whole, sometimes we try to change it to a whole number or a mixed number depending on what's going on. So when I think about this, I think 18/6, I see a relationship between 18 and 6. So I know 6/6 is 1 whole. I know 12/6 is 2 wholes. And I know 18/6 is 3 wholes. Okay, so 6/6 plus 6/6 plus 6/6, that gets me 3 wholes. Okay, there's a lot of videos that I've made about all of these topics, and this mixed number by mixed number multiplication kind of brings everything together. Okay, so if you have to go back and watch another video before you watch this one, or watch this one, go back, watch this one again, that's going to help you during this crazy time since I'm not there with you to teach you. Okay, so I knew that 18/6 was the same as 3 wholes. And so 12 plus 3 is 15. So if we were thinking about meters again, it would be 15 meters squared because we're thinking about area. All right, so let's think about what happened in all of the examples here. We thought about whole numbers, and we were used to using the area model to break up whole numbers by place value. Okay, so what we did when we got mixed number by mixed number was we split a factor up by whole number and fraction. Whole number and fraction. We carried out our multiplication like we always would, remembering all the different ways to multiply a whole number by a fraction by a fraction, bringing all the rules together. Not all the rules, but all the things you've learned together. Then, just like with whole numbers, we had to add everything up at the end, all of our subproducts. The tricky part about this was we cannot combine fractions unless they have the same size pieces. So then you also had to rely on making equivalent fractions and then adding fractions when they had the same denominator. So there's a lot of cognitive, which means stuff going up on your brain, work going into solving these problems. But you can do it, just stick with it. Okay? So what I'm going to do for you is I'm going to give you 3 examples of mixed number by mixed number multiplication that I want you to try. And if you have any questions, you can reach out. Okay, so here are your examples. To try at home, do your best, and don't forget that you cannot combine fractions unless you're working with the same size pieces. So why don't you try 2 1/4 times 5 1/4. Let's do 2 1/2 times 2 and 1/2. And let's think about 3 and 1/4 times 3 and 1/3. Okay? So, those are your 3 examples that I want you to try. The point of this video was to show you that you could apply what you know about whole numbers and multiplying them using the area model, breaking both numbers apart. And you can try that with these fractions, even though there's a couple other things that you have to be thinking about while you're working. Okay? Talk to you later.